So let's look at what happens when we have gates with more than two inputs, but they're still like AND and OR gates. So let's draw our big AND gate, right? So it kind of looks like a big letter D. And we said we've got multiple inputs, so however many that is. So let's think about how this works, right? Our rule for an AND gate is our output here, right? Our output is a 1 only if all the inputs are 1. So it's actually pretty easy to build a truth table for this, right? And kind of get an intuitive sense for how this works. The moment we know that any of the inputs are 0, we know that this output has to be 0. Just because one of the inputs is a 1 doesn't mean the rest of them are also 1s. So we have to check and see if each one of these inputs is a 1, then our output is a 1. Otherwise, for every other case, the output is a 0. And then our OR gate, which is kind of like this, I don't know, maybe you want to call it a bullet or something. And it's got multiple inputs. And so our OR gate, all it needs, or its rule, is that it just needs 1, right? It just needs one input to be a 1 in order for the output to be a 1. So that means the moment we've got a 1 here, the output is going to go to a 1. It doesn't matter what the rest of them are. As long as we know that we have 1, 1, the output is going to be a 1. So building the truth table for this is also pretty simple, right? You just have to look for those conditions where you have at least one input as a 1 and the output will be a 1. The only time we have a 0, in fact, is when, so this is a 0 now. The only time we have a 0 is when all of the pins are 0.